Now listen. Last class we started a little bit of oscillation and I told you the relation between acceleration, velocity and displacement. Remember, and we did one or two problems. Correct, Rebecca? We did one or two problems based on that.
So
now,
so can you post the video, last lecture's video on YouTube?
I already put the link, so just check it out. Already it's there.
Okay, sir.
Now listen. Last class I just did introduction of simple harmonic motion, that is oscillations. Today we are going into the chapter. So today's class will be the most important class for oscillations because today I'll be teaching you all the major concepts of oscillations. So look at the first thing. Oscillations, or sometimes it is called as linear SHM, that is simple harmonic motion, or it is called vibratory motion, or it is called to and fro motion. So there are so many names for oscillation. What is the first name that you have for oscillation? Oscillation itself. What is the other name you have for oscillation? The other name that you have for oscillation is linear SHM, where SHM stands for okay. Yes, got this much? Now, in your notebook, I want you guys to make a note of the 4 different names of oscillations. One is oscillations, one is linear SHM, one is vibratory motion, and one is to and fro motion. Written. Now let me tell you what is oscillation. Okay. Best example I can give you for oscillation is simple pendulum. I hope everyone has seen a simple pendulum. Now, how does a simple pendulum go? Look at my hand. Simple pendulum goes from here, then it goes this side, then it goes this side. Correct? Has everyone seen the motion of a simple pendulum? Now, if I take a motion of a simple pendulum, please look at the screen. If I take a, it will go to this side, correct? Then it will come back to this side and it will go to the other side, correct? Don't think I have drawn 3 different pendulums. I have drawn the same pendulum at 3 different instances of time, okay? Now, imagine it starts from position 0. Imagine it starts from position 0 and let this position be plus amplitude and let this position be minus amplitude. Now tell me, if my pendulum starts from 0, where does it go next? Can I say it goes to plus A? Now tell me, where does it go next?
0.
0. Okay, then.
Minus A.
Minus A. Continue. 0.
0.
Plus A.
0.
0
Minus A.
minus A.
Now, can I say every alternate step is 0?
Yes, sir.
Can I say every alternate step is 0 or every alternate step is the starting position? Every
Yes,
alternate step is 0 or every alternate step is starting position, and every other alternate step is extreme positions.
Yes, sir.
Every other step is extreme position. Now, this sequence is called oscillation. You should know that it should follow this sequence. Only if it follows this sequence, it is called oscillation. Now, imagine there is a person standing. Imagine there is a person standing. One minute. Now, imagine there is a person standing here. Okay, there is a person standing here. And this is right position, this is left position, and this is my center position, 0. Now, the person is at 0, and the person goes towards right. Now, to get oscillatory pattern, where should the person go next?
0.
So, from 0, the person has gone right. Then can I say it has to come 0? Okay, then.
Left.
Okay, then.
0. Right. 0
Correct.
left.
Now, if you notice, every alternate position is 0 or every alternate position is starting position, and other alternate positions are the two extremes. Other alternate positions are the two extremes. Therefore, if any body executes such type of motion, then that body is said to have oscillatory motion or harmonic motion or vibratory motion or to and fro motion. And I think the word to and fro is very common. To and fro, to and fro, correct? Now, let me give you one example again and tell me whether this is an oscillation or not. Now, this is your house. This is your house. Okay. This is CATCH25. And this is your friend's house. Okay. This is your house. Now you are outside your house. Now, first you go to CATCH25. Now tell me, if I want to follow oscillatory pattern, where you should go next from CATCH25?
Friend's house. Our house. Friend's house.
Friend's house or back to your house? Think about it.
Back to our house. Back to our house.
Back to your own
Correct.
house.
Back to your house. Okay, after that.
Then
Friend house.
Then you have to go to friend's house. Then
back to our house.
back to our house. Therefore, can I say it will be our house, CATCH25, our house, friend's house. Our house, CATCH25, our house, friend's house. By chance, from friend's house, you directly go to CATCH25, you have broken the pattern of oscillation. You have broken the pattern of oscillation. That is why one of the best examples, extremely good examples of oscillation is a sine wave. You know, a sine wave, sine theta. So can I say this is a sine wave? Everyone understood this is a sine wave. So let this be the center of a sine wave. Let this be the highest amplitude plus A, and let this be the lowest amplitude minus A. Everyone has seen a graph like this in our electromagnetic waves when we were doing this was our transverse wave, correct? Now tell me, where does the wave start from? 0.
0.
Then plus A, 0, minus A, 0. And can I say this wave will continue? Therefore, can I say sine wave is a very good example of oscillatory motion? Sine wave is a very good example of oscillatory motion because it starts at one position, goes to one extreme, comes back to one position, goes back to other extreme position. Clear? Now, how many of you have seen, let me, Let me show you one video with very good music so that you appreciate videos. Okay. Okay. One minute. I will display it in some time. Okay. Can you see the screen or it's stopped?
Stop.
Stopped.
Oh. There is a music with this ride, but bear the music. It's a very good Punjabi song. If you like Punjabi song, it's audio visual. It's a treat. Okay. Now let me display the screen again. Now, in this ride, you will notice, have you seen this ride in any amusement park, which is called Columbus ride?
Yes, sir.
Yes,
Like there is a boat, correct? This is my favorite ride in any amusement park. If you have been in this ride, you will know that all Darpok people sit on the first row and all Braveheart go to the last. Okay, if you have seen the ride. I was the person who used to sit in between because it should not look I'm Darpok also. And I'm not that brave also to sit at the end. Okay. And I have seen so many English movies like Final Destination where I feel something will go wrong anytime. So I'm always a little scared of amusement park, especially when I know it is built in India by Indian engineers who have done engineering directly after 8th standard. They have built the ride. So I'm a little scared of such rides. Okay. Now this ride, if you notice, the ride starts from mean position 0. It goes to one extreme position, let us call plus A. Again, it comes back to 0. Again, it goes to one more position, which is minus A. Remember, in this chapter, capital A always stands for amplitude. Capital A always stands for amplitude. Now, with music, we will see the video so that you get an idea of what is an oscillation in real life. After that, I will start with question and answer. Now, question and answer will not be how many people are there in the ride, nothing like that. Question and answer will be about the logic. Okay. Now, enjoy audio video and please understand in your mind 0 plus A, 0 minus A. Okay, start. Understanding? 0 positive extreme, 0 negative extreme. Now, did you understand my wording? 0 positive extreme, 0 negative extreme. In future, when I use the word 0, it means mean position. So can I say the ride starts from mean position? So tell me, from mean position, it goes to one extreme. Again, it comes back to mean. Again, it goes to other extreme. Again, it comes back to mean. Again, it goes to other extreme. So watch this. Okay, you understood. Later in the video, the ride breaks and everyone falls down. That you don't have to see. We just have to see simple oscillatory motion. Okay. Just kidding, right? Does not fall down. The whole thing collapses. Only 5 people died. No problem. In India, you know how they report news? In USA, if one dog dies, one small dog dies, dog dead. Dog by the name Pedro died. Big news. In India, population is so much. There was some stampede. Only 5 people died. Only 5. Even the news people, only 5 people died. What's there? Nothing is there. Okay. In US, if 5 people die, they'll make a national holiday. In India, I don't know how many people have to die for national holiday, but that is how it is in India, correct? But now we have to look at physics, not at biology. Okay. Now, if you talk about physics, can I say 0 plus extreme, 0 minus extreme? My question to you is, can you give me some real life examples of oscillatory motion? I told you simple pendulum. I told you sine wave. I also told you a Columbus ride. I told you simple pendulum because that is the example in the text. I told you sine wave because it is a mathematical example. And I showed you even Columbus ride. That is a real life example. Okay, Jyotika is saying swing. Swing is a very good example. Swing. Okay, very good swing. Pendulum in a clock manner, very good. Okay. Any other example? I got swing. Pendulum I told. Seesaw. Pooja is saying seesaw. Think about it. Seesaw. Possible, yes. See, mean position goes up, comes back to mean, goes down. Goes up, comes back to mean, goes down. Possible. Spring with weight attached, correct. Remember, spring is an example of oscillation because spring goes about the mean position. I'll give one biology example for you. Flapping of wings of a bird. Very good answer, Priya. Flapping of wings of a bird. See here, mean position, extreme, comes back to mean, goes down. Mean, positive extreme, mean, negative extreme. Not penguin, flying birds. Okay, flying birds. Okay, very good. Flying, okay, flapping of wings of a bird. Tell me, I don't know whether your generation has seen this device. My generation has seen this device a lot, and that device is called sewing machine. Have you seen sewing machine? It has a wheel on the side and it has a needle. Okay. Now that needle performs oscillatory motion. See, mean position down, mean position up, mean position down, mean position up. Have you seen that? Wiper of a car. Think about it. Wiper of a car. Boomerang. Correct. Boomerang. AC flap. AC flap. You know AC flap? Split AC flap. Oscillatory motion.
Yes, yeah.
Split AC flap. Fan. No, not fan. Which fan? Clapping hands. Yeah, clapping hands. Correct. Clapping hands is also, you think, oscillatory. Now think about it. Now I don't know whether this answer is correct. I got this answer from one of the JEE batches. Now I'm asking you because I am not that aware of the topic. You tell me whether it is correct. In JEE batch, when I asked this question last year, I got one answer. Heartbeat is oscillation because they said heart compresses and expands around the mean position. Now my question to you, since you're bio students, do you think heartbeat is a type of oscillation?
No. Cannot be.
Under normal circumstance. Under normal circumstance. Not when a person is running or person has high heart rate. I am not sure about the answer and nor is anyone else. But since it was an example, I am running it by you. Understood what heartbeat is? It compresses. Does heart compress and expand in a heartbeat? Does it or does it not?
Yes, sir. It
Yes,
does.
sir, it is.
Yes, sir.
Okay.
Sir,
now
but its mean position is not changing. No? It's just pumping on the point.
Is not correct.
It's just vibrating. It is not oscillating. It's just
but vibrating also about mean position is oscillation. Vibrating also about mean position is oscillation. For example, listen to this. If I take a rubber band around my hand, okay? If I take a rubber band around my hand and if I click it or if I flick it, can I say it will go around the mean position? Same like a guitar string, I will get oscillation. And if you want a very easy example, 1 minute, one example I got was swing. Tell me, have you seen a tower fan? Have you seen a tower fan? In marriages, if you see, there'll be a big fan which will be turning. Have you seen such fan?
Yes,
in
sir.
marriage? So can
Yes,
I say
sir.
that is oscillation? Fan is here, left side, center, right side, especially in marriages. So when you're sitting next to the fan with a plate, fan will come to you, your papad will fly. It has happened many times. It has happened, okay? Because fan is very strong, okay? But it's very hot also. So either you feel hot or you give up the papad. So it is up to you, the choice. Okay, so that is a very good example of oscillation. One more example I got is swing. Swing is also a very good example of oscillation. Now talking about swing, have you guys done turning of swing? In a park, there is a swing. Someone sits on it. You keep turning the swing and then you leave it. The person goes round, round, round and falls down. Have you done it? Done it? Yes. Have you stood on a swing? Standing on a swing and done like surfing? No? Okay. Boys have done it. Boys 100%. Boys have done everything. Okay. Yes. Yes. Fallen down from a swing, broken a swing. Yes. Everything. Good. Okay. Now, understood what is oscillation? Somewhat. To and fro motion. I said wiper of a car, flapping of wings of a bird, pendulum, sine wave. Just remember basketball. Yes. Basketball also is an example. Moving a ball on fingers. Moving a ball on fingers, I'll tell you. Is fan oscillation?
Is rotation.
Huh. Is it oscillation? No. Correct?
No, sir.
Is fan oscillation? No. Is moment of Earth around the sun oscillation?
No.
No. Because if it has to be oscillation, Earth has to take half circle, come back, then take other circle. Earth does not do that. Earth does complete one. Earth does not come back to mean position. Correct? So my question to you now is, which is the second question, what is the main difference between, listen to this, periodic motion and oscillatory motion? You know what is periodic motion? A motion which repeats itself in equal intervals of time. Day and night, fan, Earth around sun, all these are periodic motion. Now, what is the difference between periodic motion and oscillatory motion? That is my question. What is the difference between periodic motion and oscillatory motion? Answer is oscillatory motion is a type of periodic motion. Means oscillation is a type of periodic motion. That means any example that I give for oscillation, I am giving indirectly example for periodic motion. In other words, all oscillatory motions are periodic, but not vice versa. All periodic may not be oscillatory, but all oscillatory are periodic. Therefore, the best example of oscillation I can give simple pendulum. Simple pendulum is also an example of periodic motion. Next best example I can give for oscillation is a sine wave. Sine wave is also an example of periodic motion. Therefore, any example that I give for oscillatory motion is also an example for periodic motion, but not vice versa. Any example that I give for periodic motion may not be oscillatory. All oscillatory motions are periodic, but not vice versa. Is it clear? All oscillatory motions are periodic, but not vice versa. Did you understand this topic? Did you understand this topic? Okay, understood. Okay, so all oscillatory motions are periodic, but not vice versa. Till now, what have you written in your notebook? You have just written the 4 names of oscillation, correct? In your notebook, you have written the 4 names of oscillation till now. Can you write some examples on your own of oscillation? Can you write some examples? We have discussed so many. Write 1 or 2. Simple pendulum, sine wave, swing. So many examples we discussed, correct? Sewing machine, AC flap, wiper.
Sir, can you please explain the periodic motion again? Because I'm can't understand the difference between them.
There is no difference. Oscillatory motion is a type of periodic motion. So under periodic motion, you have many examples like circular motion, rotational motion, oscillatory motion. So oscillatory motion is a type of periodic motion itself. So the difference is what? Difference is nothing. Difference is oscillatory motion is the type of periodic motion. Therefore, every oscillatory motion has to be periodic. In other words, oscillation is a subset of periodic motion.
Okay, sir. Thank you.
All oscillatory motion have to be periodic, but all periodic motions need not be oscillatory. Okay.
Yes, sir. Thank you.
So you have written some examples of oscillation. You have written some examples of oscillation. Now write down the difference between oscillation and periodic. Write down. All oscillatory motions are periodic. Write down. All oscillatory motions are periodic. All oscillatory motions are periodic, but not vice versa. but not vice versa.
वाइस सर, वाइस के आगे
What?
वाइस के बाद क्या बोले आप?
Versa. You know the meaning of the word vice versa? VICEVERSA. Do you know the meaning of the word vice versa?
No sir.
Okay, if you don't know the meaning of the word vice versa, I will expand that. Okay. All oscillatory motions are periodic, but all periodic motions need not be oscillatory. That is the meaning of vice versa, but it is fine. Write down. All oscillatory motions are periodic. All oscillatory motions are periodic, but all periodic motions need not be oscillatory. All periodic motions need not be oscillatory. All periodic motions need not be oscillatory. Got it?
Yes sir.
Next topic, write down restoring force. Next topic, write down in your notebook, restoring force. So the topic is restoring force. Now, before I start the topic restoring force, listen to the logic. Okay, listen to the logic. I will do examples for the logic as well. Okay, now force is directly proportional to displacement. Think about it. Force is directly proportional to displacement. Now look at the screen. I'll give you some examples. Then you have to give me some examples. Okay. Now, this is bow and arrow. Correct? I have bow and arrow. Have you seen bow and arrow, everyone? At least in movies. Yes, now, don't you agree that with more force, listen to this, with more force, I pull the bow backward, arrow backward, more displacement it will go. Yes, with more force,
sir.
if I pull the arrow backward. Therefore, can I say force is directly proportional to displacement, but they act in opposite directions? That means with more force, if I pull the arrow backward, that much more displacement arrow will have forward. One more example. You know what is a catapult? You know what is a catapult? Catapult is...
Yes, sir.
What is it called in Hindi? I don't know. What is it called in Hindi? It looks like this. It is there in Angry Birds also, correct? It is like this, and in between you have a rubber band. You put paper ball, pull it back, it will go. Understand what is it called? Okay, yes. If you don't know what is that called, I will tell you an easy example. You take a rubber band in your hand and take a paper ball, correct? Take a rubber band in your hand and take a paper ball. With more force, you pull the paper ball backwards, and if you leave it, more displacement it will have in forward direction, correct? We'll not take such complicated example also. Let me take a simple example. With more force, you put the tennis ball downwards. Can I say that much it will bounce upwards, that much higher it will bounce upwards with more force, correct? You also have something called pullback car. Have you seen that pullback car? I don't know whether in your generation you have pullback car. In my generation, there was a car, toy car. You pull it back, it will go forward. More you pull it back, more it goes forward. Now, have you seen something called as trampoline? Trampoline, you know, people jump on that. Okay.
Yes, sir.
Yes, sir.
In Malad, there is a place called Bounce also, where you can jump on the trampoline. Now, can I say with more force I jump on the trampoline, which more force I give downwards, that much more up I will go in opposite direction. We'll not take such complicated example also. Let us come back to very simple example. In swimming, with more force, if I put my hand backward, my body will go that much forward. Swimming, correct? Now, if you have played with a click pen, you know, click pen on your desk. On your desk, if you put the click pen down, it will jump up. Have you done that in class with the click pens? Okay, I used to do that a lot. Click pen is there. You put the click pen down on the desk, it will jump. You used to feel very happy with that click pen. Okay, especially when the class is going on, one pen is flying up. It is good. Okay. And if you have seen wrestling, there are 3 rings on the edges, correct? In wrestling, can I say with more force, the wrestler falls on the ring, more he can go on the other side with more displacement. Okay, now I have given so many examples where force is directly proportional to displacement. That means what? More force, more displacement, but in opposite direction. More force, more displacement in opposite direction. If you play basketball, you will know that if I want to jump higher, or any person who wants to jump very high, first they bend down a bit. Once they bend down, and then they get that much of extra displacement. Okay, it is a very common thing. I've given so many examples. Now I want you guys to give me some examples where force is directly proportional to displacement in opposite direction. Okay. There is a saying in Hindi also. There is a saying in English also. It is related to this. Jab sher do kadam piche leta hai. Have you heard that shairi? Yes, when a tiger takes 2 steps back, that means the tiger will pounce forward. Have you seen that? Have you seen a cat or have you seen a tiger hunting? Before they pounce, first they go back a little bit and then they pounce. Okay. Give me more examples. Spring, correct? Spring you take, listen. With more force, you compress the spring. And when you leave it, more it will jump outside. Okay. Yes. Any other example? Bow and arrow, boat and the oak. Correct. Priyanka. You know, boat, the oak, you know, oar of a boat. Traditional boats, you know, traditional boat. We have something called oar, like a bat, like a paddle. We have to do it. Volleyball, yes, volleyball also. Give me more examples. Heading a football. Javelin throw, yes, Kanak, very good. Javelin throw is the very in flavor now, correct? More you put your hand backward, more javelin will go forward, correct? Very good. Any other example? When you want to slap someone with full force. Have you heard the saying in Hindi? What is the saying in Hindi? If you want to slap someone with full force, you have to put hand backward. More you put your hand backward, more displacement, more force. Correct? Don't try it now. Just example. Okay. Then anything else? Till now, what is happening is I'm giving example, you're telling yes, yes, yes. I want you to tell me example, I'll be telling yes, yes, yes. Okay, start. Stretching a rubber band, elastic band, yes, Pooja, correct. Vivek hitting a football, correct. Kanak volleyball, javelin throw, Priya, correct. Punching is also correct. Priyanka boat is correct. Neha, spring, correct. Priya, volleyball. There is one example which I did not give because I thought I will leave it to you. because it's a very direct example, which I did not want to tell, so that I thought you will tell. You have also not told me. Day-to-day example, direct. Think about where force is direct, but in the opposite direction. Where force is directly proportional to displacement. Vibration of branch. Okay, Ramesh. Walking, okay. Walking. You will come to know that example colliding with each other. Yeah. There are some games where blowing a balloon, yes. There are some games where you have some protective gear around you and you have to go and dash the other person. Have you seen that? Around you, there is like a plastic ball completely. Another person also has a plastic ball around that. And you both come and you dash. With more force you dash, more you will go other side. It is there in all the games, like Takeshi's Castle and all it was there. Okay. Okay, but generally, I hope you got the logic, correct? Force is directly proportional to displacement. That main example will come in the chapter in some time. That time you'll understand, okay, this was also an example. Okay. Now, force is directly proportional to displacement, but can I say they act in opposite direction? Therefore, can I make this statement? Or can I say this relation is correct? Force is directly proportional to displacement, but force and displacement act in opposite directions. Acting in opposite directions mathematically can be represented by a minus sign, correct? Acting in opposite directions can be represented by minus sign. Therefore, F is directly proportional to minus X. If I remove the proportionality sign, I will get equal to constant into X. Correct? If I remove the proportionality sign in physics, I get constant. This formula is called my restoring force formula. This formula is called my restoring force. But in the module or in the textbook, they have directly given the formula F equal to minus kx by 100. Now, I wanted to let you know that you should understand how did that formula come. Now, can I say you know how the formula came? Force is directly proportional to displacement, but it takes place in the opposite direction. Therefore, F is directly proportional to minus X. If I replace the proportionality sign, I get equal to constant. Therefore, F is equal to minus Kx. F is equal to minus Kx, where, now listen to this carefully, where F is called restoring force, where F is called restoring force, X is the displacement, and K is our spring constant, where K is our spring constant, okay, or a force constant. Therefore, write down this formula, then I'll explain this formula in detail. Write down F is equal to minus Kx, where F is your restoring force, K is your spring constant, and X is your displacement.
Sir, why is there a negative sign before displacement?
I give so many examples last 20 minutes. Why there is a negative sign? Because force and displacement act in opposite directions, correct? You give force in one direction, displacement happens in other direction. That is why negative sign.
Okay, right, understood.
Can anyone predict or can anyone tell me what is the SI unit of force? What is the SI unit of force?
Newton.
Newton, correct. What is the SI unit of displacement?
Meter.
Meter. Therefore, looking at the formula by doing mixing and matching, like how you mix and match nail polish and all that, tell me what should be the unit of spring constant.
Kilograms seconds.
Kilogram second means, oh my god, how kilogram second? No, I got it how kilogram second. Anyone else? What should be the unit of spring constant?
So kg per second square.
Kg per second square. I want in terms of Newton and meter.
Newton per meter.
Newton per meter, correct? Can I say the unit of spring constant is Newton per meter? Tell me how many of you understood how. Put your answer in the message. Yes or no? Understood? Yes or no? The unit of spring constant is Newton per meter. Okay, most of you have understood. Okay, now let me come to the topic. F is equal to minus kx. From this formula, can I say k is equal to minus f by x? Correct. Therefore, F is Newton, x is meter. Therefore, the unit of spring constant is Newton per meter. Now, let me tell you something about spring constant. You directly have the formula for spring constant as m omega square. You directly have the formula for spring constant as m omega square, where, listen to this, k is your spring constant. K is your spring constant. M is your mass. Can anyone tell me what does omega stand for? By now you should have studied it. What is omega? Angular frequency. What is omega? Angular frequency. What is omega? Angular frequency. Okay. Let me take one step back and let me tell you, which is the first formula that you studied today? The first formula that you studied today is restoring force, correct? Now, restoring force is what? F is equal to minus kx. Tell me the formula for k. M omega square. Does anyone know the formula for omega by now? Or does anyone know the formula for omega? Anyone? Anyone knows the formula for omega?
Frequency. Omega per second. No,
angular frequency, correct? Angular frequency. Therefore, frequency with an angle is called angular frequency. Frequency with an angle is called angular frequency. What is the total angle that you have in geometry? Total angle that you have in geometry is 2 pi, 360 degree. Therefore, the formula for omega is 2 pi f, or listen to me carefully, omega is 2 pi by t. Tell me how many of you understood this to this. At least by now you should know frequency is the reciprocal of time, correct? Because unit of frequency is second inverse. Therefore, instead of writing frequency, can I write 1 upon time? Instead of writing frequency, can I write 1 upon time? On your screen, you have 4 most important formulae. The first formula is of restoring force. Second formula is of spring constant. Stop, listen first. The third formula is of angular frequency, which is not a new formula. Means this is not a formula that you are learning in this chapter. This is a formula which you're supposed to know already, but maybe you have not done the chapters of part 1 where omega has come, so you don't know. But these 2 formulae are already known. These 2 formula are there in the chapter for the first time. Therefore, if I tell you which 4 formula did we learn today, what you will tell me? Listen to me. You'll tell me, sir, we learned 4 formula. I'll tell you, very good. Tell me the 4 formula. You'll tell the first formula that we learned is restoring force. F is equal to minus kx. Over there, k is spring constant, whose formula is m omega square. Over there, omega stands for angular frequency, whose formula is 2 pi f or 2 pi by t. Understood? How do you say the answer? Shall I repeat once, or you understood? Repeat? Yes, once more. Good. F is equal to minus kx, restoring force formula, where k is called spring constant. K spring constant's formula is m omega square. M omega square, where m is mass and omega is angular frequency. Omega is angular frequency, and the formula for omega is 2 pi f or 2 pi by t. The formula for angular frequency is 2 pi f or 2 pi by t. Can you make a note of all this? You know, angular frequency, the formula is so easy. It is frequency with an angle. What is angle? 2 pi. Tell me by now, everyone knows 2 pi is 360, pi is 180, pi by 2 is 90, pi by 4 is 45, pi by 3 is 60, pi by 6 is 30. Do you know all this? Or should I give you a table of degree and radian? Should I give you the table?
Table, sir.
Yes, sir.
Yes, sir.
Table.
Yes, why not? Why not? Yeah, I'll give you. I will give you, but first make a note of this. Okay? Start writing. Nothing better to do on a Saturday afternoon than to study physics. That's what you're thinking. I am telling it loudly. Okay? So yes, till 4 o'clock, nothing better. After 4 o'clock, you keep doing biology, your favorite subject. Okay? From 4. Yes, finished. Now we learn 4 formulae today. You learn 4 formulae today. One is restoring force is F is equal to minus kx, k is equal to m omega square, omega is equal to 2 pi f or 2 pi by t. Clear, all of you, with this much. Now, for many people who are not sure with radian and degree, no problem. We'll make a table, okay? Just one small table where I write in degree. And I write in radian. So 0 degree is 0 radian. 30 degree means pi by 6 radian. 45 degree is pi by 4 radian. 60 degree is pi by 3 radian. 90 degree is pi by 2 radian. 180 degree is pi radian, and the highest angle 360 is 2 pi radian. Okay, make a note. So if I say sine 45 or sine pi by 4, it means the same. Okay. Okay, done. So last class I told you to read some medical journals, have some understanding about some proper readings. Have you started that already? Have you started that? Reading journals. Last class I told you about it, correct? Did I tell your batch about it? The medical report, you try to read it and all that, correct?
Yes, sir.
Or no? Tell me please. Have you started? Okay, okay. Okay, I will tell you. In the next class, I will tell you. In the next class, I will show it to you. I will download it in my device and I will show you the app in my device. Okay, just remind me. Okay. WhatsApp, I am not active on WhatsApp that much because even though I'm active, it is not me using it. Okay, it is my team who uses my WhatsApp. So if you have experience that you have WhatsApp me, I have not replied. I've seen it is not me. That is why any questions or any doubts, if I have not responded, you please send a reminder, and every 2 days keep sending reminder because I am not using it. My team uses the WhatsApp. Okay. So in the class only, I will show it to you. Okay. Now we will continue with oscillations itself. Easy till now, oscillations is easy. So now you know what are the other names for oscillation. You know the example of oscillation. You know the difference between simple harmonic motion, that is the difference between periodic motion and oscillation. You know the formula for restoring force. Correct? Think in your mind. Do you know the formula for restoring force? Yes. Do you know the formula for spring constant K? Yes. And do you know the formula for omega? Omega is angular frequency, 2 pi f or 2 pi by t. Does anyone know what is the SI unit of frequency? Anyone? What is the SI unit of frequency?
Hertz.
Per second.
Per second or hertz? Both are correct. Hertz or per second. Okay. Now, let us do some more analysis of oscillation. Some more analysis. Okay. Now, okay. Now, can I say this is my mean position in any oscillation, and this is my extreme position in oscillation? I am taking the example of simple pendulum because it is easier to explain. Okay. Now, tell me what is displacement at mean position. For example, again, I will show you the video of the Columbus ride. Okay, that boat. I think it is called Scream Machine or Columbus. I don't know what is it called in Magic. Now, whatever. Okay, now, the boat in the amusement park. When you go and sit in the boat, will the boat be in mean position or will the boat be in extreme position when you're going to sit for the first time? Which position the boat will be in, mean or extreme?
Mean.
Mean, correct?
Mean.
You go to sit and the boat is in extreme, then don't sit in that boat, okay? Because either the boat is not working or you're entering midway between the ride. Both ways it is risky. So can I say at mean position, the displacement is 0 because the boat has not started to move anywhere in the initial stage. Now the ride starts. Now think about it. Be in the ride, be in the ride. Okay, now the ride starts. Initially 2 to 3 oscillations will be like, so kiddish, so nice. Then the actual ride starts. Then can I say once it reaches the extreme position, my displacement will be maximum? Do you agree that once it reaches the extreme position, it is at the farthest distance from the center or farthest distance from the mean position? Therefore, you learned 2 new formulae directly. What are the 2 formulae that you have learned? Listen to me carefully. Keep your camera on. What are the 2 new formulae that you have learned? At mean position, displacement of a body is always 0, which is minimum. At mean position, displacement is 0, which is minimum. And at extreme position, displacement is maximum. And what is the value? Plus or minus A. At extreme position, displacement is maximum. I think it is self-explanatory, because when you go to extreme position, can I say your displacement will be maximum? Because you have gone to the extreme. Do you understand? So tell me, did you understand? Don't write now. I will give you time to write. Now listen. So 2 new things you have come to know. What are the 2 new things you have come to know? One is displacement at mean position is what? 0. Minimum. And what is displacement at maximum? That is displacement at extreme position, maximum. And what is the value? Plus or minus A. What does A stand for?
Amplitude.
Amplitude. Now again visualize that you are in a ride. Tell me at extreme position, what will be the value for velocity? Think about it. At extreme position, what will be the value for velocity? Okay, now let us go to the ride again. Okay. Again, the music will start. So just see, at extreme position, the velocity will be 0. Check. Because the boat will come to a stop, because it has to come back down. Imagine if the boat does not stop at extreme position, tell me what will happen. Tell me what will happen. Imagine you're in a boat and at the extreme position, boat does not stop. It keeps going. Can I say you will take a complete circle and fall down? Okay.
Yes.
Very
Yes,
good
sir.
to see. Very good to see, but very bad to be in it. Correct? So if you see the boat and if it goes to the extreme position, can I say at the extreme position, it has to stop because it has to come back down. And only when it can come back down, when it can stop at the extreme position. Otherwise, if the boat does not stop at the extreme position, can I say it will complete a circle, which is not oscillation, correct? So look at this. It goes, stops over there. Understood? Stops at the extreme position. Now, can I say at this point, it is at maximum distance from the mean position, correct? Displacement is maximum. And can I also say velocity becomes 0? As velocity becomes 0, look at the boat. As velocity becomes 0, it will come back down. Understood? Therefore, can I conclude at extreme position, velocity is 0. Otherwise, it will somersault. Somersault will take a complete circle. Okay. Also, tell me what will be the velocity at mean position. Think about it and tell me what will be the velocity at mean position. Can I say velocity at mean position will be maximum? Look at the ride again. Listen to me and look at the ride. When it crosses the mean position, just look at the boat. When it crosses the mean position, it crosses the mean position with so much of velocity so that it goes to the other end easily. When it crosses the mean position, the boat goes with maximum velocity because it has to go to the other side. Just notice. Understood? Then it stops. Then again, when it passes the mean position, just check the velocity. Velocity at mean position will be maximum. What is the value? I don't know, but I know that it is maximum because with full speed, it comes down. Just notice mean position and just notice the velocity of the boat when it crosses the mean position. Okay, did you understand? Now, if I go back, I came to know 2 more things. What did I come to know? I came to know that velocity at extreme position is 0, which means it is minimum. And I came to know that velocity at mean position is maximum. I don't know the value, but I know it is maximum. I don't know the value means today I don't know the value. In future, you will know the value. It is not that no one knows the value. You don't know the value as of now. It is not an answer. It is just one understanding. Velocity is maximum at mean position. It is not an answer. For example, if your parents ask you, how much did you get in your exam? You tell them, in my whole class, I got maximum. Is that the answer to their question? Yes or no? Answer is no. It gives them an idea. It gives them an idea how much you got, but it does not answer their question. I will repeat. If your parents ask you, how much did you get in your exam? You will tell them, in my class, I got maximum. Now that gives them an idea how much you might have got, but that does not give them actual answer. Now, if you tell your parents, I got maximum in class, it happens with my parents, it happens with Indian parents. They will not praise you. They will think all other people in your class are dumb. They'll think, what happened? Other people did not perform. How come you came first? Okay, that is the first reaction. Then later on, you will come to know. So, can I say I came to know 3 direct formula, but I came to know 1 relation, that velocity is maximum at mean position. Okay. Now I will ask you Viva. And the questions that I'll ask you in Viva are, I will only ask, I will answer now, then I will ask you. Can I start the questions, what I'm going to ask you? Okay, listen. The first question that I'm going to ask you is, tell me some other name for oscillatory motion. Now, the other names are many, and in that word you saw vibratory motion. You know a shaving trimmer. Have you seen a shaving trimmer? Shaving trimmer. That motion is also oscillatory. Just check. No? Shaving trimmer. Okay. Yes, sir. So that is the first question. Second question I'll ask you is, give me some examples of oscillatory motion. Third example I'll ask you, or third thing that I'll ask you is, what is the difference between oscillatory motion and periodic motion? Fourth question I'll ask you is, tell me the formula for restoring force. Fifth question that I'll ask you is, tell me the formula for spring constant. Sixth question, what is the formula for omega? Seventh question, what is displacement at mean? Eighth question, what is displacement at extreme? Ninth question, what is velocity at mean? 10th question, what is velocity at extreme? So on and so forth. What is the unit of restoring force? What is the unit of force constant? What is the unit of frequency? What is the unit of time? What is the unit of displacement? Blah, blah, blah. It is 2:10. I will start my Viva at 2:13. In the meantime, if you have any doubt, you can ask me. Start revising. Please copy this in your notebook. Okay, let us start with the best part of the class, which is Viva. Okay. Now, on your screen, I will show some important points that might help you clearing the Viva. Okay. Yes. Now we will start. Okay. Now we will start with who wants to volunteer? And I will go first. I will go first. Anyone volunteer? Very good. Worry. Worry has volunteered. Very good. Worry, unmute.
Yes, sir.
Tell me some names for oscillatory motion.
Yes, sir. Oscillatory motion is also known as vibratory motion, to and fro motion, and simple harmonic motion. A linear simple
Right.
harmonic motion.
Okay. Rebecca,
Yes, sir.
tell me 2 to 3 examples of simple harmonic motion.
So the examples of simple harmonic motion are swing, a simple pendulum, the flapping of the bird's feathers.
Bird's wings, not feathers. Bird's wings, correct? Feathers, correct? Okay, fine. Okay, fine. 1 minute. Okay, next person will be Adrita.
Yes, sir.
2 questions in one. Okay, 2 questions in one. What is displacement at mean position and what is displacement at extreme position?
Displacement in mean position is 0 and in extreme position it is maximum.
Okay, this is for everyone. If I ask this question again, Adrita, even for you. If I ask you what is displacement in mean and extreme, how you're supposed to answer is displacement in mean position is minimum, which is 0. And displacement at extreme position is maximum, which is plus or minus A. Okay, Adrita, but you have answered correctly. Jyotika,
Yes, sir.
what is velocity at mean position and what is velocity at extreme position?
Velocity at mean position is maximum. We don't know the value. Velocity at the extreme position is 0, which is minimum.
Okay, correct. Very good. Okay, Kanak.
Yes, sir.
Kanak, tell me the formula for restoring force.
F is equals to minus kx.
F is equal to minus kx. Priyanka. Priyanka, are you there?
Yes, sir.
Priyanka, tell me what is the formula for spring constant?
For what, sir?
Spring constant.
Spring, it is equal to m mass into omega square.
Okay, correct. Akshay.
Yes, sir.
What is the correct answer, Pooja? Correct answer. What is the formula for omega? Both the formula.
Sir, 2 omega into frequency, and frequency is 1 upon time. So the second formula will be 2 omega upon t.
2 omega upon t or 2 pi by t?
Sorry, 2 pi by t.
Correct. Okay. Pooja.
So the formula of the omega is 2 pi frequency or 2 pi upon time. We have replaced
Sonal. No. Sonal.
Yes, sir.
Sonal, tell me what is the difference between periodic motion and oscillatory motion?
All oscillatory motions are periodic motion, but all periodic motions are not oscillatory motion.
Other people have not switched on your cam. This is a very interesting situation we are in now, because all of you will be in the waiting room and you will be telling that, oh, why are we in waiting room? And then you will start complaining, and then I will come back, and then we'll have a long case. Okay, other people have switched on. Okay. Okay. So the people who have asked question, I will not ask question again in my next Viva. My next Viva will be at 3 p.m. And for people who have not answered, we'll have to answer. Okay. So now, Viva will keep getting tougher and tougher, and level will go higher and higher. Okay. So we'll continue. Shall we continue now? Now, last we left it over here. Okay. Now, I will have 3 formulae. What will I have? I will have 3 formulae. And those 3 formulae, you have to directly remember as formula for velocity, acceleration, and displacement of oscillation. Yeah, it was right, Sunil. It was right. Okay, now listen to this. Listen to this. Now, what is the formula for acceleration of oscillation? What is the general formula for acceleration? That means in oscillation chapter, listen to me carefully. In oscillation chapter, if I want to find acceleration, Ramesh, where is Ramesh?
Yes, sir, I'm here.
Ramesh, your camera has a problem? Ah, I can see.
No, it was off.
Formula for acceleration of oscillation. Now, you know the general formula for acceleration is velocity upon time or dv by dt. That is general formula. But look at the side heading. The side heading says what is the formula for acceleration of oscillation. What is the formula for acceleration of oscillation? And the formula is acceleration is equal to minus omega square x. This is the formula you guys should remember. Now, what is the difference between acceleration is equal to velocity upon time and this formula? The difference is that formula can be used in any chapter because that's a general formula. But this formula can only be used in oscillation chapter because look at the side heading. Side heading is, it is the formula of acceleration only for oscillation. That means only for bodies performing oscillation, I can use this formula for acceleration. But acceleration is equal to velocity upon time can be used in any subject, any chapter, anytime. Understood the difference? That is why that formula becomes a general formula. This formula is only to oscillations. That is why the side heading is not formula for oscillation. The side heading is formula for oscillation, acceleration of oscillation. That means in other chapter, I cannot use this formula. Please remember, in other chapter, if some other sir asks you what is the formula for acceleration in that chapter, you cannot say minus omega square x. You can use this formula only when the body is performing oscillation. Now, can you predict what does omega stand for and what does x stand for? Think and tell me.
X is
What
for
does omega stand for and
displacement
what
and
does X?
omega stands for second per second.
Omega stands for angular frequency, correct? Omega stands for angular frequency, correct? And what does X stand for?
Displacement.
Displacement.
X stands for displacement. Therefore, make a note of this particular topic. Formula for acceleration of oscillation. Formula for acceleration of oscillation. A is equal to minus omega square X, where A stands for acceleration, omega stands for angular frequency, and X stands for displacement. And X stands for displacement. Now, the next topic. First topic is formula for acceleration of oscillation is omega square X, that you have to remember. Now, next topic will be so this is the next formula. That is the formula for velocity. Again, I will repeat. Just like acceleration formula can be used only in oscillation, this formula for velocity also can be used only in oscillation. And what is the general formula for velocity? Displacement by time, correct? That formula can be used in every chapter. But this formula, plus or minus omega root of a square minus x square, can be used only in oscillation. Now, many times what people do is they make a mistake in remembering. They write omega into a square minus x square. That is a formula. They write a into omega square minus x square or x into a square. They get confused. Therefore, you can remember the code word wax, W-A-X. That means this is how it comes. First omega comes, then a comes, then x comes. So make a note of this formula, quick. So now the new set of Viva questions that I'm going to ask, the first question that I'm going to ask is, what is the formula for acceleration of oscillation? What will you answer? Minus omega square x. Remember it right now. The second question that I'm going to ask, what is the formula for velocity of oscillation? What will you say? The formula for velocity of oscillation is plus or minus omega root of a square minus x square. Now the third formula that I'll ask in the Viva is, what is the formula for displacement of oscillation? Acceleration over velocity over. Now I'll give you a formula for displacement of oscillation. Now write down the side heading. Formula for displacement of oscillation. Now look at the screen. Right, x is equal to a sine omega t plus phi. Phi means it's just a constant, okay? You know, when you integrate something, you have to put plus c. If you have studied integration somewhere. I have studied integration somewhere in the first module.
Yes, sir.
There it is done. So can I say when you integrate something, answer will be something plus c, correct? Something plus c, integration. So that plus c over here is plus phi over here. So make a note of the formula for displacement. X is equal to a sine omega t plus phi. Where x is displacement, a is amplitude, omega is angular frequency, and phi is your phase constant. Now I will ask you 3 questions in Viva, okay? What is written after P? Nothing is written after P. There is no P in my formula. Pooja, there is no P in my formula. That's a phase constant. PHAS, phase. PHAS, phase.
Then constant, no?
Yeah, phase constant, correct.
Thank you, sir.
Now, the 3 questions that I'm going to ask you for this Viva is, what is the general formula for acceleration of oscillation? What is the general formula for velocity of oscillation? And what is the general formula for displacement of oscillation? I'll fill it for you. A is equal to minus omega square x. Velocity is equal to plus or minus omega root of a square minus x square. and x is equal to, these are the three things you should remember. Make a note. Made a note, study 1 minute, then the next round of Viva will start.
So we have to say what the term stands for?
No, not necessary.
Okay, sir. Thank you.
Now, I have 3 formulae for displacement in this chapter. Listen to me. I have 3 formulae for displacement in this chapter. One is formula for displacement of oscillation is A sin omega t plus phi. Second formula is what is displacement at mean position? 0. What is displacement at extreme position? Plus or minus A. Do you understand? Now I have 3 formulae for displacement. One is the formula for oscillation. One is displacement at mean, and one is displacement at extreme. Understood? Which class you have after this?
No, sir.
Nothing,
No
right?
class.
Okay, good. Okay, Rashi.
Yes, sir.
Rashi, tell me what is the formula for acceleration of oscillation?
It's minus omega square into x.
Plus minus or only minus?
For acceleration, only minus.
Ramesh.
Yes, sir.
I cannot see you, Ramesh. Yeah, Ramesh is correct, Ramesh. Ramesh, tell me what is the formula for velocity of oscillation? You're on mute. You're on mute.
Sorry. Plus minus omega square root of amplitude minus square root. No, it's not square root. Square of displacement.
Square of amplitude minus square of displacement. Okay. Palak.
Yes, sir.
Palak, tell me what is the formula for displacement of oscillation?
X is equal to plus minus omega. X is equal to A times bracket omega t plus K.
Muskan.
Yes, sir.
Muskan, tell me, very easy question, okay? Very easy question. Tell me what is the SI unit of displacement, SI unit of velocity, and SI unit of acceleration.
So in acceleration or something.
Anyway, it doesn't. Unit does not change.
So this acceleration is meter per second and displacement का meter per second velocity is same.
What is it for displacement?
So meter per second.
Displacement is meter per second. Okay.
So,
Velocity?
sorry, meter.
Meter. Okay. Then velocity?
Velocity meter per second.
And acceleration?
So meter per second square.
Correct, Pooja.
Acceleration meter per second square.
Acceleration meter per second square. Who confirmed it? The notes confirmed it. Correct, Muskan?
Yes, sir.
Oh, very nice. Okay. Mahi.
Yes, sir.
Mahi, I cannot see you. Okay, Mahi. Yes, now I can see. Mahi, tell me, what is the formula for acceleration of oscillation? Mahi, I am waiting for your answer. Mahi and our class are going in parallel universe. Correct, Mahi? Pooja, correct? Mahi, what is happening? Why not concentrating? Tell me, Mahi, what's the problem? I cannot hear you, Mahi.
Sir, nothing.
Now I can hear you. Now it's in.
Sir, nothing.
No problem. Other answer.
Sir, I don't know.
Exactly. Then what's the problem? Not happy. Not happy. Aisha.
Yes.
Aisha, tell me the formula for velocity of oscillation.
Plus minus omega root a square minus x squared.
Plus minus omega root a square. Okay. Now, my next topic, all of you. Listen to this. Find the value of acceleration at mean position. This is the task I will give you for 1 minute. Try to get the answer. What is the value for acceleration at mean position? Start. Then I will tell you how to do it also. This is the task I am giving you to solve. What is the acceleration at mean position? Okay, now listen. I got some answers, but the problem is I have camera off of many people. So again, camera on. Now listen. What is the acceleration at mean position? This is the question. How do you start the answer? You start the answer like this. I know the formula for acceleration is minus omega square x. Everyone knows this formula for oscillation. And I also know do I also know this? At mean position, my displacement is 0. Do I already know this? At mean position, x is equal to 0. Therefore, if I put x is equal to 0 over here, can I say therefore acceleration at mean position is 0? Now look at the graph. Not look at the graph, look at the diagram. Now, can I add one more thing in this diagram? Check. Jyotika, just for you we are doing. Okay, just for you we are doing, Jyotika. Yes, Jyotika, look here. Just for you we are doing this diagram. That acceleration will be 0 at mean position, which is minimum. Can I add this now? Because I have just done the derivation. So, do the derivation first. This is the derivation. Find the acceleration at mean position and then add this point in the diagram. Start. Everyone understood the derivation? Everyone understood the derivation? Yes, make a note. Once you're done writing, put a dot. Okay, now next topic. Next topic. Now, similarly, try to find, I'll write the side heading of the next topic. Try to find the answer. Start. Pooja, got it?
Yes, sir.
Okay, I got answers from most of you. Now let me show you the answer and then you confirm whether the answer is same. The beginning is the same. The beginning will be, I know the value for acceleration. Listen to this. I know the value for acceleration is minus omega square x, correct? Now I know that at extreme position, x will be equal to plus or minus a. I already know it. Now, if I substitute x is equal to plus or minus a, I will get a is equal to minus omega square plus or minus a, or I'll get acceleration is equal to plus or minus a omega square. And this value will be maximum value because at mean it was minimum. Therefore, at extreme it will be maximum. Therefore, I can add one more thing over here. Everyone please look at the screen. I can add one more thing, that acceleration at extreme is a omega square, which will be maximum. Easy. So again, look at the derivation and tell me if you have understood. And that is why this formula can also be called as A max, because it is maximum value for acceleration. Make a note. So now listen to this. Listen to this very carefully. You will have how many formulae for acceleration you know? Tell me now, how many formulae for acceleration you know? Now you know 3 formulae for acceleration. For oscillation, tell me, which is the first formula for acceleration that you know? I know the general formula for acceleration is minus omega square x. This is my general formula for oscillation. Now, next one is acceleration at mean position is 0, and that is minimum, correct? Therefore, can I say acceleration at mean is 0? And I also got one more formula, that acceleration at extreme is equal to A omega square, which is maximum. Now, can I say in this chapter itself, I have got 3 formula for acceleration? So if I ask you, what is the formula?
It should be plus minus, no?
Plus minus, I'm ignoring. Plus minus means one side and other side. I'm ignoring plus or minus. Okay. Now listen. If I ask you, tell me the formula for acceleration. Normal question. If I ask you the formula for acceleration, you will tell me minus omega square x, because that is the general formula. But if I tell you what is the value for acceleration at mean position, you will answer that at mean position acceleration is minimum, whose value is 0. If I ask you what is acceleration at extreme position, you will tell me acceleration at extreme position is A omega square, which is maximum. Now, similarly, you have 3 formulae for displacement. Can you tell me which are the 3 formulae for displacement you already know in this chapter? One is the general formula for oscillation, A sine omega t plus phi, correct? This is the formula for oscillation. Now, which is the next formula that you know for displacement? I can say displacement at mean position is 0, which is minimum. I also know displacement at extreme position is A, plus or minus A, which is maximum. Easy, easy. Now let me go to the next derivation. I'll complete 2 more small derivations. With that, 60% of the chapter is over. 2 more small derivation, and I'll write the side heading, try to get the answer. And the question is, start. This is your task. Okay, I got answers from many of you. Now let me start. Tell me, with what formula do I need to start? I need to start with the velocity formula itself. Now, can I say velocity general formula for oscillation is plus or minus omega root of a square minus x square, correct? This is the general formula for velocity of oscillation. Now, can I say at mean position, x is equal to 0. Now, if I put x is equal to 0 in mean position, I will get v is equal to plus or minus omega root of a square minus 0 square. Or I will get v is equal to plus or minus omega root a square. Or I will get v is equal to plus or minus omega a, because square root of a square is a. Therefore, can I say velocity at mean position is plus or minus a omega, which is maximum, that I already knew 1 hour back, that velocity is maximum at mean position. But now I also got the value, that is a omega, correct? Therefore, value for velocity at mean position is plus or minus a omega. Therefore, if I go back to the page of the diagram, over here, I had written question mark, correct, for velocity. Now I can remove this and I can write velocity is equal to a omega, which is maximum. Understood?
Yes, sir.
So I will go back to this page. Now you guys make a note. And I'm very happy most of you gave me the right answer. And this is good. I'll do one more Chotu derivation and then I'll start with the summary again. That is the revision. So make a note of this.
Sir, I have one doubt.
Yes, tell me.
Sir, the displacement extreme formula.
Displacement extreme formula is plus or minus a.
I didn't understand. I did not understand that formula.
Yeah, so tell me displacement is maximum. I showed you with the Columbus boat also. That boat goes maximum, correct? And maximum is amplitude. So at the extreme position, can I say you are at the largest distance from the start point, correct? At extreme, you are at the largest distance from the start point. And the largest distance from the start point is your amplitude. That is plus or minus a. That is why displacement is plus or minus a. For example, look at this. Everyone look at the screen. If I take a sine graph, this is plus a, this is minus a. Now tell me, where is my displacement maximum? Tell me which point. Tell me, where is my displacement maximum? Can I say my displacement is maximum at this point?
Yes, sir.
Or it is maximum at this point, correct? What is this point? And what is this point? Therefore, in general, can I say is the maximum displacement?
Okay, sir.
Understood.
Understood. Thank you, sir.
Now, my next and my last derivation for the Chotu derivation series is, write down, I know that you know the answer already, but now you have to prove it. I know that you know the answer, but I want you to prove it mathematically. Start. Okay, now I will start. You know what is the answer? Answer will be 0, correct? You know that the answer will be 0, but let me prove it mathematically. Now, I know the general formula for velocity is plus or minus omega root of a square minus x square. This is the formula for velocity. Now, at extreme position, x is equal to plus or minus a. Now, if I put x is equal to plus or minus a in my formula, I will get v is equal to plus or minus omega root of a square minus a square, because plus or minus a square is a square itself. Or therefore, can I say v is equal to plus or minus omega into 0? Therefore, velocity at extreme, is 0, which is minimum. You already knew this answer, correct? From our video. But this is mathematically we proved that velocity is 0. Okay? Now, okay, finish it. Okay, now let us do a recap. Now, please understand this very well. We will take the summary again. Now we'll take a pendulum and this will be our mean position. Okay, let me do it again. And we will take the extreme position also. Okay, now listen to me carefully. We will take the extreme position also. Now we have to find the value for displacement, velocity, and acceleration at mean position. We have to find the value for displacement, velocity, and acceleration at extreme position. Now, how many of you can fill all 6? Please raise your hand. It's not like this in the icon. Please let me know I can fill all 6. Only 2. Only 2 people can fill all 6. Only 2 people can fill all 6. Not no one more. Okay. 3. Okay, good. Okay. Don't worry, if you feel you cannot fill all 6, no problem at all. Success is not meant for everyone. Success is meant only for few people. So again, we'll continue. Okay, now let us see. Displacement is, listen to this. Now I'll repeat once and after that I want all hands to go. Okay, now listen to this. Displacement at mean position is minimum, which is 0. Velocity at mean position is maximum, which is a omega. Acceleration at mean position is minimum, which is 0. This completes everything about mean position. Any doubt? Okay. Now, coming to extreme position, displacement at extreme position is maximum, which is A, actually plus or minus, but I'm ignoring the signs now. Velocity at extreme position is minimum, which is 0. And acceleration at extreme position is maximum, which is A omega square. Therefore, this is my next answer. Tell me, is it clear now? Now, can you do this without seeing once? All the complete page, try to recreate it without seeing. And if you're stuck, look at the slide that I'm showing. Okay, start. Okay, done. Okay, now one more task for you. Pooja, fine, but make a note of your mistake and next time don't do it. Okay. Now, all of you, one task for you. I want you to I want you to write 3 formulae for displacement that you learned in this chapter. Start. So I will tell you the answer in some time. Before that, tell me 3 formulae for velocity that you learned in this chapter. Start right now. 3 formulae for velocity that you learned in this chapter. And 3 formulae for acceleration. Start for this chapter. Thank you, Pooja. Okay, now let us do a recap what you have done. Okay, now full class revision will happen here before I start the Viva. Now listen to this. We started first with F equal to minus Kx, correct? Our restoring force. Everyone, please look at the screen, keep your camera on and understand I'm going to explain for the next 5 minutes the summary. Now everyone knows this formula, think in your mind along with me. Here, K will be m omega square and omega formula will be 2 pi f or 2 pi by t. This was the first thing that we did. Now let me come to displacement. Now the general formula for displacement is A sine omega t plus phi. This is the formula for displacement of oscillation. The second formula I have displacement at mean, which is minimum, which is 0. Next formula I have is displacement at extreme, which is maximum, which is A. This covers everything about displacement. Now let me come to velocity. My velocity general formula is plus or minus omega root of a square minus x square. Now velocity at mean, I know it is maximum and the value is a omega. And velocity at extreme, I know it is minimum, it is 0. Then we did acceleration. Now I know the general formula for acceleration of oscillation is minus omega square x. Then acceleration at mean is minimum, which is 0. And acceleration at extreme is maximum, which is a omega square. Now, all of you got it? And I gave you the summary diagram of the pendulum. This summary diagram. I had given one more. Where is that? Yeah, this summary diagram everyone should know. And this diagram to draw it 3 times is your first homework for today. Make a note. This diagram to draw it 3 times is your first homework for today. Okay. And 3 formulae for velocity, 3 formulae for acceleration, 3 formulae for displacement. 5 times you have to write the formula to prepare. Means this one. 3 formulae for displacement, 3 formulae for velocity, 3 formulae for acceleration. 5 times. Okay, so your homework till now is so much. Now we will continue with the class. Tell me before I continue, are you comfortable with so much? Because next class I'm going to start from the module and I'm going to directly start with the problems, and all the problems will be from all this formula that you have done. So next class I want the formula to be very strong. Today you might make some mistakes, you might forget, but by next class you should be very, very strong. Now my question to you is, I'll give you 1 minute to get the answer. What is A max divided by V max? Tell me the answer. A max divided by V max. Got the answer? I got answers only from 4 people, which is surprising. Answer is not A omega. Answer is not A omega. In fact, A will not come in my answer. Very few people gave me the right answer. Let me read out the names also. The people who have given me the right answer. Rashi has given me the right answer. Rebecca has given me the right answer. Druska, just check your answer once. Almost right. Asta, check your answer once. Pooja, check your answer once. Jyotika, correct. Akshay, you need to understand the question. Priyanka, correct. Ramesh, check your answer. Okay. Now, okay, I will tell you what is A max upon V max. The question is, what is A max upon V max? So look at this. I know that A max upon V max. Now, what is the value for A max? A omega square, correct? And what is the value for V max? A omega, correct? Therefore, can I say A and A? Omega and omega will cancel. Therefore, omega. Therefore, this formula is a shortcut formula which will help you a lot. That means, listen to me, stop. If in the question, Akshay, stop, listen. If in the question, if A max, 1 minute. If in the question, if A max and V max are given, listen to me, only these 2 values are given. Can I find out the time period of oscillation? Think about it. If in the question only A max and V max are given, can I find out time period? Answer is yes. You know how? Because I know that A max by V max is omega, and I know omega is 2 pi by t. Therefore, can I say if A max and V max are given, I can indirectly find out time, or I can indirectly find out even frequency, f. So, with Maximum acceleration and maximum velocity are given in the question. You can easily find out most of the things. Correct? Now tell me, what is the formula for time period? Any one formula for time period that you know today?
Sir, but Vmax is 0, na?
Vmax is 0.
Vmax.
What is maximum velocity?
Yes, velocity at mean is a omega.
Did I say mean? I just said maximum velocity. And I said maximum acceleration. I didn't say at any position, because maximum acceleration happens at extreme position and maximum velocity happens at mean position. I did not say find the ratio at mean, or I did not say find the ratio at extreme. What did I say? What is the ratio of maximum acceleration to maximum velocity? Understood? Because
yes,
A max won't come and V max won't come. I want maximum value of acceleration. I want maximum value of velocity. Now, I will tell you time period of oscillation can also be written in this formula. T is equal to 2 pi root m by k. My challenge to you is, can you find out how? You already know the formula which will give you this. Can you find out? Challenge question. Can you show me how can I say time period is equal to 2 pi root m by k? I will make the challenge little less tough. I know the formula omega is equal to 2 pi by t, and I also know the formula k is equal to m omega square. I'm giving you, look at the screen. I'm giving you golden clue. Using this formula and this formula, I can get this formula. Think about it and start. Very few people are still getting the answer. I said Rami's got it, very good. Vari got it. Aisha got it. Muskan got it. Akshay got it. Pooja got it first. Very good, Pooja. Jyotika got it next. Akshay got it after that. Driska, did you get it? After the clue. Rashi, good. Okay, now I will derive it. Again, it's very simple. You guys tell me whether you have used the same logic. And for people who have not got it, Please see it and tell me if you have understood. Okay, now look at this film. I know T is equal to 2 pi root m by k, that I have to prove. So now can I say from this formula, can I write T is equal to 2 pi by omega, correct? Simple. Now from this formula, I know that omega is equal to square root of k by m, because omega square is equal to k by m. Therefore, omega is equal to square root of k by m. Now in this formula, can I write T is equal to 2 pi divided by omega is square root of k by m? Or can I say it is 2 pi if I take it on top? Easy.
Sir, can you explain again?
I'll explain in a blank page so that you can understand it better. T is equal to 2 pi under root m by k. This is I have to prove. And I know two formulae. Tell me the two formulae that I know. I know omega is equal to 2 pi by t. Everyone should know this formula. And I also know k is equal to m omega square, spring constant formula. Do I know these two formulae? Yes. Then, from the first formula, I can write T is equal to 2 pi by omega. I can write it like that. And from my second formula, I can write omega is equal to square root of k by m. Correct? Now put that value of omega over here. Therefore, I will get T is equal to 2 pi by under root k by m, or I will get 2 pi into root m by k. This is the formula for time period of oscillation. Therefore, if I ask you the formula for time period of oscillation, again, do you realize this formula for time cannot be used anywhere else? This formula for time is only for oscillation. T is equal to 2 pi under root m by k.
Sir, can you show the previous slide? Sir, not this one.
This one?
Yes, sir.
Okay.
Done, sir.
Are you getting heavy on the brain? Is it getting too much for you? Is it getting too much for you, or you're okay? I'm not taunting. I'm not actually making fun. I'm asking you sincerely. Is it getting too much, or you can absorb? Because I'm going to start a next topic which is heavier. So are you in the mental state of mind to absorb, or shall we do problems only based on this much? Or are you ready for a new topic? Answer sincerely. I'm okay.
Sir, problems.
Problems. Okay. I'll give you some problems, try to solve. Okay. I'll give you some problems, try to solve.
Excuse me, sir.
Yes.
Or in that last thing that we did, how this omega came down over here?
See, you understood this formula?
Yes, sir.
Now, if I take T over here, omega will come down. So T went up and omega came down.
Yes, sir. Yes.
Got it?
Thank you, sir.
Now I'll do 2 to 3 problems. I want to start the next topic. Next topic is around 55 to 60-minute topic, which we can stretch it because you don't have a class. But by looking at your face, you're ready to press the leave button already. So we'll do some problems. And one good thing is I'm doing the problems from the modules so that when we do the module, I can tell you that this we have done it. Okay. So now I'm just dictating. Now look at this. Maximum acceleration is given as 80 meter per second square, and maximum velocity is given as 20 meter per second. Find out what is the frequency of oscillation. Start. This is your first question. Okay, anyone answer? Any answer?
So I got 1/90.
People are giving me answer for angular frequency. I don't want answer for angular frequency. I want answer for frequency. Okay, I think. Okay, we'll do it. We'll do it. We'll do it. So can I say I can write A max by V max is actually omega. I already proved it, how it is omega. And that A max is 80, V max is 20. Therefore, omega is 4. Everyone, first step or the first answer you should get is omega is equal to 4. Are you getting that much? Now, can I say omega is 2 pi f equal to 4? Or f is equal to 4 by 2 pi, or it is 2 by pi hertz. That's it. No need to simplify. Here pi is not 90. We are not converting degree to radian. Here pi is 3.14 only. Actual value of pi, 3.14. It is not pi radian. It is only pi. But you can leave the answer as 2 by pi hertz. Tell me if you're getting this answer.
Substituted the value of pi as 3.14.
Yes, you can do that. Then you'll get 0.8 something. Getting it? All of you?
Sir, in the place of pi, I put 180.
Don't put 180 because that is pi radian. Here you're not talking about degree and radian. Here you're just talking about pi as 3.14.
Okay, sir. Thank you.
Can we go to the next one? Okay. Easy question. I'll just not give you the wordings. I'll give you the data directly so that you can easily solve. Omega is given as 4. Amplitude is given as 5. Displacement is also given as 4. Find the acceleration of oscillation and velocity. Not maximum, normal acceleration and normal velocity. Start. 6424, something like that. Getting 6424.
Yes, sir.
Some people are getting it 6424. Okay, 64 and 12. Some people are getting 6424. Some people are getting 6412.
Yes, sir.
Okay, I will solve it. You tell me whether you are also getting the same answer. Now find acceleration. I know the formula for acceleration is minus omega square x. So acceleration is minus omega square is 4 square into 4. Therefore, acceleration is minus 4 square is 16 into 4, which is 64 meter per second square minus 64 meter per second square. Correct? And velocity, if I want to find, velocity formula will be plus or minus omega root of a square minus x square. Therefore, velocity is equal to plus or minus omega is 4 under root of a square, it is 5 square, which is 25, minus x square is 4, which is 16. Therefore, v is equal to plus or minus 4 into square root of 25 minus 16 is 9. Therefore, v is equal to plus or minus 4 into square root of 9 is 3. Therefore, v is equal to 12. So answer is 12 and 64. Are you getting that? Answer is 12 and 64. Are you getting this answer?
Yes.
Okay, very good. Now the same question
Sir,
I'll ask you. Yes, yes.
So sorry to disturb, but sir, it will be plus or minus 12, na?
Correct. It will be plus or minus 12. I'm ignoring the sign. Whenever I don't put the sign, I am ignoring it. You know why? Because plus 12 on the right side, minus 12 on the left side. Here in this chapter, plus minus means one is happening on the right, one is happening on the left. That way. Same question. Can you find out maximum acceleration and maximum velocity? Can you find? Same question. Can you find maximum acceleration and maximum velocity? Can you? Or in other words, listen to me. Stop. I'll tell you my final intention only. I'll tell you my final intention. Can you find out time period?
So can you repeat?
Okay, find out maximum acceleration, find out maximum velocity, and find out time period. In the same question, can you find out maximum acceleration, maximum velocity, and time period?
So we will try.
Said something I could not hear.
So we will try.
Yes, try. Find A max, V max, and time. Okay, done? Now, listen to me. Listen to me. What is the formula for A max? Tell me what answer you're getting. A max is equal to A into omega square, correct? Now tell me what is the value of A? 5 and omega is 4. Therefore, can I say 5 into 4 square? Therefore, 5 into 16, correct?
Yes, sir.
Therefore, what is A max?
80.
80 meter per second.
I think I'll get disconnected from the session in this screen. Let me know if my screen goes on.
The screen is visible.
Screen is visible. So A is 80. Now tell me what is the value for V max?
20.
20 meter per second.
A is 5. This is 4. Can I say we came back to the previous question?
Yes, sir.
Yes, sir.
Yeah. So can I say time also will be same as previous question? Check.
Time will be pi by 2.
Pi by 2.
Correct. Same as previous question. Previous question frequency was 2 by pi. So time would be pi by 2, correct?
Yes, sir.
I think I got disconnected right now. Wait. Anyway, not necessary now. Okay, now. Is everything clear, all of you, for today's class? Is everything clear?
Sir.
Okay. Okay. So, your homework is that pendulum diagram, which I had showed you. You have to draw that 3 times. And velocity, acceleration, and displacement, you have to draw it 5 times. Is it clear? Now, many of you are asking me for break. There is no break, okay? There was 1 to 4. If you want a break from next time, we'll put it in the timetable. Priyanka, what did I not find? Tell me.
Sir, time.
Time, I told you it's the same thing, right? Like the previous one. Can I say time will be pi by 2? Second. Priyanka, time will be pi by 2.
Yes.
Now, we have completed 60% of the chapter. And 40% what is remaining, I'll tell you. We have 3 topics remaining. We have kinetic energy, potential energy, total energy. That is one topic. Total energy of oscillation. And there is one topic called simple pendulum. Means I have to analyze simple pendulum. So that is 20% each. But I will not do that right now. What I will do in the next class is I will start with the module problems of whatever we have completed, so that you get complete idea about what is the formula used for. And then I will go to energy and pendulum. Is it fine? Okay. So in my next class, what I will do is I'll try to put a break in between for 15 minutes. Okay. So you will have a class from 1 to 4:15. That means you'll have class from 1 to 2:30. 2:30 to 2:45, we'll have a break, and then we'll have a class again, because otherwise you guys are getting saturated. It's fine. 3 hours continuous, it's a heavy thing. So from next class onwards, I'll put in a break of 15 minutes in between. Okay. So keep revising this much. Actually want to start a new topic. I have some time left, but both the topics are 1 hour plus. So I will give you the liberty today. Next class we will cover. Okay. Not that you're complaining, but it is fine. Okay. If I leave it to you, you will not mind even if I leave at 1:30. Correct? Very happy. Very good. Saturday afternoon. Please keep revising. Any doubt in the next class, please tell me the doubt before I start the class for this chapter. Okay. And in the next class, remind me about the app of medical, which you can follow for daily updates for medical and field of bio. So with that, we can stop for today. Any doubt in today's class, you can stay back. I can discuss whatever I thought. If you are clear with today's class, you can log off. Okay. But if you have any doubts, I am here. You can ask. Muskan, the homework is the pendulum diagram. You have to draw it 3 times. And the formula for velocity, displacement, and acceleration. 3 formulae each. You have to write it 5 times. Is it fine? Thank you, Pooja. Bye-bye.
Bye, sir.
Bye, Pooja. Bye, Manus.
Thank you so much, sir.
Thank you. Thank you, everyone. Thank you, Jyotika.